Alright, hey everyone, today I'm actually going to make a correction on the last video I made for line integrals. So, remember this example? There were a few things wrong with the physics part of it. So, what I should have clarified was, I should have said, the work done by gravity on the object is 0. So let me explain what's going on here. The big idea still remains the same, but there are a few vectors that I need to change. So, yesterday in S1, when we take the dot product of G dot H, we actually need to do cosine of 180 degrees because the gravity vector is pointing down, but the H, our direction vector, is going up. So there's 180 degrees between them. But what does this mean? What does the minus sign mean here? This is very interesting. Gravity is doing quote-unquote negative work on the object. So, when I lift up this marker, gravity is sucking out the potential energy. Gravity is sucking out the kinetic energy of this object. That is why when I fight against the force of gravity, I must exert a force upward in order to continually replenish the kinetic energy that this object must have in order for it to move upward against the force of gravity. However, because this is negative work and we're moving upwards, the potential energy of the object increases. Notice that as I lift it, it has more potential energy. And so, in this case, let me denote this point by x naught, y2. And our original point is x naught, y naught. So the 0 just means a naught. In this case, let's say the object moves upward. That means our potential energy at this point right here is greater than the potential energy right here. However, sacrifices were made in order to bring the object up to this point. That was what I meant by supplying continuous kinetic energy in order for it to move up here. Because when we move up here, we're trading off kinetic energy for potential energy. For S2, the angles are 90 degrees apart. So the object's moving this way, but gravity is pointing downward. And so we have 90 degrees between these two vectors. That's why this turns out to be 0, and our final result is 0. Let's take a look at S3 next. So, in this case, gravity and the vector h are pointing in the same direction. So, we get a positive result. What does this positive result mean? Well, it means that gravity is doing positive work on the object because the result is positive. So, gravity consumes the object's kinetic energy right here, and gravity consumes the potential energy of the object right here, and translates that into kinetic energy. That's what we mean by positive work. And for S4, I'm not going to do it, but just know that it's very similar to S2, because these two vectors are also 90 degrees apart. In this case, let's call this x2 and y2. in this case, the potential energy function right here tells us that it's actually, oh, sorry, this should be x2, and this should be y0. So, the potential energy function tells us that this is actually less than the potential energy function evaluated at the point here. And I hope this kind of clarifies some things up on the last example, because I got a little mixed up between my force and the gravity force. So let me move on a little bit here. There was one other mistake I made in the last few minutes of the last video, and that is work is actually the change in the kinetic energy. I'll symbolize it as KE here, but in the other video, I made a mistake of saying that work is the change in the potential energy, which is not the case. Work is actually the negative of the change in potential energy. So what happens is, as kinetic energy increases, our potential energy decreases, for this example. And as the kinetic energy increases, the potential energy decreases, and vice versa. If the potential energy increases, you lose kinetic energy. So, I should have actually written, in the last few minutes, I actually should have written work is equal to the line integral of g dot dr equals to minus u x naught y naught z naught minus u of x naught y naught z naught. This was for the case where they all return to the same point, and so our final result is 0. The only difference is I have to add this minus sign over here. So let me explain a little more on why we need to add this minus sign. But when I related the math definition of the line integral to the physics definition, the big concepts still remain the same. This is still our vector function. This is still our scalar value. And u is still our potential function, little f. I just need to explain the minus sign over here. Let me check if I'm short on time. Good, we still have some time. All right, so. Let me just focus on S1 here, because the value actually isn't 0. So, in S1, here's a gravity vector g pointing down. Here is our normal vector n going up. And in order to lift the object up against the force of gravity in the first place, I need to exert a force of equal strength, so equal magnitude, and in the opposite direction. So I'm going to call this my force. All right, here we go. So, because work is change in the kinetic energy, here is our line integral g dot dr, and it's equal to minus the change in the potential energy. So here's our original point. I'm going to assume we're in 3 dimensions now. So we're going to be at point ABC here for x, y, z, and we're going to bring it up to D, E, G. DEG. So we're bringing this object in three-dimensional space from ABC in the XYZ plane to D, E, and G. And here's our integral expression. So, in this case, we're losing kinetic energy here. What happens is the potential energy increases. So this is a positive value. But let's say I didn't apply my force. Let's say I threw this marker up, this eraser up. So originally it'll have a velocity, and so it has kinetic energy. But as it reaches the peak, it loses that kinetic energy. And so work is actually going to be a negative value, because the change in the kinetic energy from when it first had velocity to when it no longer had any velocity is 0. If we talk about a change in the potential energy instead, this is actually going to be equal to the change in the potential energy is now going to be the line integral of my force, the force I supply going upward. And now we don't need to add a minus sign, because the potential energy clearly increases as you supply the object with energy for it to go upward. Alright, I hope this correction was enough to help clarify things. Let me know if you find any other mistakes, and good luck.